All right, gang, Math 1500, more on normal distributions. This is going to be a super short video, the kind that I'm sure you're going to come to like. Sometimes I'm going to get really windy, and well, it's just going to be a long video. What can I say? But this was really just looking at another type of problem that we run into in normal distributions. Uh, let's let's just kind of review a little bit, and if you think that you're beyond review and you are like an expert at this stuff, just fast forward, okay? But let's say that we want that we have a normal distribution that has a mean equal to 30 and a standard deviation equal to 3. Well, we know that this distribution is going to be centered at 30, and one standard deviation above the mean is going to be 33, and one standard deviation below the mean is going to be a 27. So we're going to construct our standard, our normal distribution. No, that was absolutely horrible. That's just, look, guys, that's just ugly. Pretend I drew that the way I was speaking, but gosh, that's horrible. But anyway, pretend it's pretty. But anyway, that's what the distribution would look like. If we want to get fancy, we can use that normal PDF stuff that I showed you in the previous video. So in something like this, if we have, again, just concentrating on this, this mean of 30, standard deviation 3, if we want to look at the probability that we select some value from that, that's between, say, 26 and 34, for example, just as an example, we can easily work this type of problem on our calculator using the normal CDF key, just as we've shown before. So we'd run that thing from 26 up to 34, mean of 30, standard deviation 3, paste, hit enter, and we get our answer of 0.8176, rounded to 4 places. I checked Hawks, and it seems like that they're obsessed with 3 places in some problems, so this would be 0.818 because that fourth digit 5 is 5 or bigger. So if just report it according to what they request. All right. Now the purpose of this video, I mean, this is all fine and dandy, but I think I've covered this adequately in the previous video. The purpose of this video is to look at a different type of problem that we encounter in normal distributions. And the goal of this is to find a score from a normal distribution with a given characteristic. So that's the goal of this. So no longer finding a probability, a percentage, a proportion, anything like that, but to find a score from the distribution with the given characteristic. I'll tell you what, guys. Let me see if I can focus. It doesn't seem like this is focusing as well as it should. Okay, that looks a little bit better. All right. So something we may want to do here is let's say that. Let's just go back to our old buddy IQs, because I'm such a fan of making important decisions based on one test score. And this, of course, will be an aptitude test. But let's say again, and we get our normal distribution here. Mean of 100. Standard deviation 15. And we have the following type of questions. What IQ represents the 48th percentile? Now, you got to think back to the definition of percentile, which I covered in a previous video. Percentile is just what? Percent below. So we can use a little bit of educated knowledge here, and we can say, well, we know that 100 is at the 50th percentile because 100, the mean in any normal distribution, splits it into two equal parts because we have perfect symmetry. All right, so that's cool. So we know that there must be some IQ score right here that has 48% of the IQs below it. Again, because percentile, by definition, is percent below, and we're looking at the IQ score, which we don't know, that has 48% of the scores below it. Well, guys, it turns out we have a handy-dandy key on your calculator that works these types of problems called inverse norm. An inverse norm, unlike normal CDF, requires you to put in 3 entries and not 2. So inverse norm requires 3. If you put in 4, it's going to give you an error. It's just not going to work. So what you do here, the last 2 things are still the mean and the standard deviation, but what goes here is percent below as a decimal. Percent below as a decimal. Now for this problem up here, what do we want? Well, we want 48% below, and we know 48% as a decimal is 0.48. We know the mean of IQs, which we're dealing with here, is 100, and we know the standard deviation is equal to 15. So gang, what we can do here is we can just go to second function distribution, come down to number 3 instead of number 2 that we've used previously for the inverse norm. We want our area to be 0.48. We want our mean to be 100. And we want our standard deviation to be 15. Come to paste, hit enter again. So gang, the IQ that is at the 48th percentile is a 99. Or if you could round up and call it, say 100. So 99 technically has less than 48% below it. So we would, I don't know. I would round it to 99 for that. Now I was going to say something and I got lost. Oh, I'll tell you what I want to do. I want to show the other calculator here. So the other calculator is just going to work similarly. So second function distribution, come down to number 3, inverse norm. So here we're going to have 0.48, comma 100, comma 15. So really we get the same thing we get the other way in the end, and certainly get the same answer. So if you got this kind of calculator that has this type of operating system, this is the way you use it. Or if you got a newer calculator, you've got the newer operating system, which would be the way I demonstrated on the computer. So guys, really, if you just kind of stay on your toes, let's say that ACTs form a normal distribution with a mean of 21, standard deviation of 5. So let's shift that up a little bit to get closer to what it currently is in 2014, 2015. And let's say that a highly prestigious university will only consider applications in the top 5%. So to give you an indication of what this problem looks like, we have some ACT here that separates the top 5% with the bottom 95%. It is so tempting to get careless here and do inverse norm 0.05 because that's the value given in the problem and get the problem wrong. That's, guys, that's just not going to work for you. Remember, the inverse norm requires you to put what right here? Percent below. And up here, we've got the percent above, so we have to adapt the problem. Well, we don't adapt the problem, we adapt what the information from the problem to put it in the calculator to give us the correct answer. So guys, at the end of the day, to get the top 5%, we have to put percent below, which is 0.95. So guys, probably most of you have taken the ACT, so just to give you an indication, to be in the top 5%, it means you have 95% below you. Let's just use a mean of 21, a standard deviation of 5, which is pretty close. Paste it. So guys, you got to get an ACT of about 29 to be in the 95th percentile. So you know, 29 is a really, really good score, obviously, on the ACT. Now, what if I ask you something like this? Let's take some random normal distribution. It's probably going to help if you can see what I'm doing. Some normal distribution. I'll tell you what, let's just go back to IQs. And we want to know the two numbers and we'll cover this because there's actually, so the IQ number 1 and IQ number 2, that separates the center 30% of the distribution of scores. Now, the thought process on this type of problem should be the following. First of all, you're not being asked to find something that starts with a P. You're not being asked to find probability, proportion, percentage, yada, yada, yada. So the normal CDF key that I taught you in the previous video does not apply. You are being asked to find a score from the distribution. Actually, you're being asked to find two scores from the distribution. So your guys, the key that's going to apply here is the inverse norm. So let's focus on this one right here. What do we need to be able to work inverse norm? Percent below. So guys, if I got 30% between here and here, and I want to find the middle 30%, it tells me right off the bat that I am missing 70%. 100%, you know, under the curve, we do all IQs. We don't just do like 90% of them. We do all of them. So if we take 100% minus 30%, we know what goes out here and what goes out here. Well, because of symmetry, I can divide this equally to see that I have 35% in each area. So does it add up to be 100? Well, I got 35 plus 35 is 70, plus the 30 gives me 100%. So I have accounted for, in this distribution, 100% of the information. To find this score, what am I going to do? Well, I'm going to look at percent below, 0.35, comma 100, comma 15. What am I going to do here? 0.30 plus 0.35, so 0.65 to get the other one. So gang, what I can do is use my calculator, go inverse norm. So I want 0.30 below, 0.35 to find the IQ1. So that's going to be a 94.22. So I'm going to write that down. And then for the other one, I'm just going to go second function entry here because all I need to do is just change one number. I just need to change that 0.35 to 0.65. 0.3 plus 0.35. So I get 105.78. All right, gang, so back here on presenter, I've written the 105.78 and the 94.22. Now, let's say you get a problem like this on your first exam, which you will, and you look up at the clock and you've got about 15 minutes and you're kind of like, I'd like to know, is that right? Is 94.22 and 105.78 right? So when I walk out of here, I may not know about the other 29 questions I did, but I can be sure of this one being right. Is there a way that you could test that? Yeah, you could. Let's put those values back in our calculator and calculate the percentage and see if it corresponds to what we need. So if I come back to normal CDF, which will calculate the percentage, and I go 94.22 up to 105.78, with a mean of 100, standard deviation 15, when I paste this into my home screen and hit enter, what should I get? Well, if I got the right answer, I should get something awful close to 0.30, 30%. And you can see I do. I get something awful close to 0.30. So I would feel comfortable handing in my test knowing that I at least got one question correct on this one. And chances are if you got that correct, you got a bunch of them correct because that'll be one of the harder questions that'll be on the first exam, which should be really good news to you because that's not one of the tougher types of questions. All right, gang, I want to bring up, I want to do one more thing. I want to just bring up R and show you how these types of problems are worked on R. Just in case you haven't got your calculator yet, R is free. So it's kind of cool to see how, well, it's kind of cool to have something free. What am I talking about? So let's just work a couple of problems. Let's work the following. Let's say, again, let's just go with IQs, forming a normal distribution, and let's just work some problems. First of all, what's the probability that an IQ is greater than 108? What's the probability that we get an IQ between 92 and 110? What's the probability that we get an IQ less than 120? And between what two values, two IQs, does the center 80% lie? Now these are going to be really easy to use with the calculator. Let's do that. All right. So let's just go to the calculator. I want to clear out and get started with new stuff. So if I'm going to work part number one, IQ greater than 108, starts with a P. So I'm going to go to normal CDF. I'm going to go 108 up to E99. Mean of 100, standard deviation 15. So the answer to the first problem is going to be 0.2969. The next problem we want is between 92 and 110. So the answer here is 0.4506. The next question is below 120. So below 120, our lower bound is going to be negative E99. Go up to 120. Paste it and work it. So we're 0.90. 88. I'm writing this information down, so we'll have it at our leisure. All right. The other problem takes a little bit more work, between 80%. I like to just draw these out. Doesn't have to be pretty. Doesn't even have to be to scale. But I know I want between 80%. So how much am I missing? Well, I'm missing 20%. Put half of it here. Put half of it here. So to work the first problem, I'm going to do 10% below. To work IQ2, I'm going to have 90% below. So guys, got a different key, different dynamic here. Inverse norm. So I want the first one, I want 0.1. 100. Comma 15, well 15. So that's going to be 80, let's just call it 80.78. And I'm just going to go second function entry here because all I need to do is change the 0.1 to 0.9. And sometimes if you don't draw a picture, this one is easy to miss. But if you draw the picture, you see that you have two percentages. Let me show you that. You have two percentages. You have this one and this one that's below that value. So drawing a picture really helps get these things correct. So I'm going to go 119.22. Now, how would you work these same problems on R? Now that we've got the correct answer, and we know we do, how would we work the same problems? Well, guys, there's a p-norm option, and p-norm always gives you percent below. So since the first problem, I'll tell you what. Let me get out of here and do some teaching before we start punching buttons. When we're on R, these types of problems are worked with two commands. The normal CDF equivalent on the TI calculator is p-norm. And the p-norm has three values. The p-norm has your score. It has the mean, and it has the standard deviation. This will always give you percent below. Now I'll show you how to manipulate that if we want percent below or percent between. The inverse norm key on the graphing calculator is given as Q norm. And Q norm has three values that you have to put in. Obviously the mean and the standard deviation, and it turns out this works exactly like the calculator. Percent below is a decimal. All right, so let's see how we would work these four problems. I think it'd be kind of helpful here if I got into a split screen situation. Let's see if I'm clever enough to pull something like that off. Hopefully I can make that happen. All right, gang, so if I'm going to work problem number one over here on R, I want percent below. So I know that the total area is 1. So I'm going to take 1 minus the p-norm of 108, comma 100, comma 15, and I will get the same answer. Now, if I've got the situation where I've got between 92 and 110, now this is harder. This is much harder on R than it is on the other, because what I have to do is I got to be tricky. P norm always gives me percent below. So what I've got to do first of all is I've got to look at my upper bound of 110, calculate that area all the way down to negative infinity. And then I've got to come in and subtract 92, subtract this part out to leave me the part in the center. So guys, to be able to pull this off, I'm going to have to go P norm, the bigger number, minus the percent P norm, the smaller number. Was 92, right? Yeah. And guys, that'll give me my answer just exactly like what we got before. Now guys, if your problem, like the number 3 there, if your problem is just strictly below 120, then you know life is good. It's just a direct entry, and so you get 0.9088. Now the other one, we've already set up the problem between what two IQs does the center 80% fall. Guys, this is again just like the graphing calculator. Q norm, just percent below. So we'll find the left bound at 80.78. And I'll show you a feature. If you hit your up arrow, it will go up and bring the previous command down. So all we need to do there is just change, I'm about ready to sneeze, 0.90. And of course you're going to get your 119.22. So take a screenshot of this. This encompasses compared to these problems, how you can do these problems on R. So, those of you might be saying, well, Darbro, I haven't got a calculator yet. I lost my calculator. Dude, this is free. This is free. You can download this. Again, R is a free software and comes with absolutely no warranty. But guys, the stuff we're going to work, it does a good job. All right, gang, I'm done. Let's it's a beautiful day. And I'm sitting here looking at my kayaks and my boat, and I'm thinking, it's time for me to go out on the boat. All right, I was going to do some other stuff, but I'll be good. All right, gang, that's the end. Take care.